operators part 1. In this video, we'll look into Python operators. Following are Python operators: arithmetic operators, assignment operators, bitwise operators, comparison operators, logical operators, identity operators, and membership operators. Let us look at some examples of these. Let us look at some examples of arithmetic operators. So arithmetic operators are basically addition, subtraction, multiplication and division, basic operators. Let us take an example. 1 plus 2, 3, 1. Let us say divided by 2. And print this. Here the result. Save it, debug, start with our debug. So it is 3. The answer is, so that's how we can use this basic operators. The other operator is modulus. Modulus gives us the remainder. Let us see an example. Print 2 modulus is represented by percentage symbol. 2 modulus 2. Let's see this example. 2 modulus 2 is 0. The remainder will be 0. So it has given us the remainder. So the modulus operator gives us the remainder. Let us see an example for exponentiation. That is squared or cubed. Let us print 2. Exponentiation can be given by double star. 2 double star 3. That means 2 cube. Let us see debug. Start with is 8. 2 cube is 8. It has given us the result 8. The other is the floor division. So if I say int, here let me write it down. This is the modulus. This is modulus operator, which is percentage symbol, and this is exponentiation, that is double star symbol, is 2 cube is 8. Now let us see what is floor division. Let's say 7. Double division by operator is floor division. 7 by 3. Let's see what it will give us. Is 2. 7 by 3 is 2. So it has rounded off to 2. It should be 2 point something. It should be 326 and then 3 1.2.3. So 0.3 it has taken out and then it has given us 2. So this is what we call this floor division. Let us see another example of floor division. Print 7 by 4. Let's take the calculator. Say 7 divided by 4 is equal to 1.75. Let's see the example. It has given us 1.75. But if I do a floor division, double division, start with it will give us 1. The answer is 1 because It has not considered 0.75. Here also it has not considered that 0.3. So these two examples are for floor division. This is for exponentiation. This is for modulus, and these are the basic addition, subtraction, multiplication, and division. So these are the arithmetic operators. Assignment operators. X is equal to 1. So we are assigning 1 to x. Print x. It is printing 1. Now we can assign in another way. X is equal, let us take y is equal to 2 and x plus is equal to y. Now if I print x, this means x plus is equal to y means x is equal to x plus y, that is equal to 1 plus 2 is equal to 3. So here when we assign in this way x plus is equal to y, then the answer we should get should be 3. Let's comment this part out because this is just an explanation. Now debug, so it has printed 3. So initially x is 1, and for that we are adding y. That's how we represent added it. Instead of x is equal to x plus y, you can as well say that x plus is equal to y. Similarly, we can say x minus is equal to y, x into is equal to x star is equal to y, or x modulus is equal to y. So all other operators you can use to represent in this way. So these are the ways you can assign the operators. Now let us look at some comparison operators. Say comparison operators. Print 1 equal to 1, 1 equal to 1. Print 1 not equal to 1. This is equal to and this is not equal to. Let's see these two first. First one is 1 equal to 1 is true, and 1 not equal to 1 is false. So let us see other comparison. Just print 1 is greater than 2, print 1 is less than 2, print 1 is greater than or equal to 1, print 1 is greater than or equal to 2. So let us run this. So first one is 1 is equal to 1 is true. Second one 1 is not equal to 1 is false. 1 is greater than 2 is false. 1 is less than 2 is true. 1 is greater than or equal to 1 true. And 1 is greater than or equal to 2 is false. So that's how we can use these comparison operators. Now let us look at logical operators. The operators. So AND is the logical operator. 1 is equal to 2 and 1, 2 is equal to 2. So if it is AND logical operator, then both the conditions should be true. Otherwise it will be false. Because 1 is not equal to 2. So let us print this. 1 is equal to 2 and 2 is equal to 2. Start with it. So it is false because 1 is not equal to. So with AND operator, both the conditions should be true. Now if we take the same thing, say OR instead of AND, and let's run it, we get true because with OR operator only one of those conditions should be true. This condition is true, so this or this. If both the conditions are true, it is 1 equal to 1 and 2 equal to 2, then both the conditions are true. So with AND operator also this you will get true. So here we got. Now the same thing, we can negate this. Let's say this not. If you say not, then it is negating it. This. The first one is false because 1 is not equal to 2. Second one is true because 1 is equal to 2 or 2 is equal to 2. Third one is 1 is equal to 1 and 2 is equal to 2 is true. Fourth one is 1 is equal to 1 and 2 is equal to 2. We are negating with not. So it is false.